This is the third part of the lesson on solubility. So up to this point, we have learned a number of tricks that we have in our toolbox for solving problems involving equilibria, and we're going to apply pretty much all of them to understanding solubility of ionic compounds. So this is an example of where we're going to break out our knowledge of Q versus K to predict whether or not a precipitate will form. So we're given a problem: if 100 milliliters of 0.1 molar calcium nitrate and 100 milliliters of 0.1 molar sodium carbonate are combined, immediately at the instant the solutions are mixed, what's the concentration of calcium and carbonate? So let's draw a picture to try to help ourselves understand this. So we have 100 milliliters of 0.01 molar calcium nitrate, and we're going to add that to another beaker containing 100 milliliters of 0.10 molar sodium carbonate. And so when we do that, normally we're going to take a shortcut here and we're going to assume that the volumes add. Sometimes the problems will tell us that. If they don't, we're going to have to make that assumption. So we're going to assume that when we combine these together, what we're going to get is 200 milliliters of solution. That's not really the case if you were to do this in a lab setting, but it's going to be good enough for now. So we're going to assume 200 mils total volume. All right. Now, there's a couple of ways now to solve this problem. We have a solution of 0.01 molar calcium nitrate that now has a volume of 200 milliliters. We could do C1V1 equals C2V2 as we did first semester. Concentration 1 times volume 1 equals concentration 2 times volume 2. We could do that and solve for the concentration of calcium and then solve again for the concentration of carbonate. However, what we're going to do here is we're going to take a shortcut. We're going to notice that we go from 100 milliliters to 200 milliliters of the calcium solution. So over here, the calcium would have a concentration of 0.01 molar calcium ions. So if we double the volume, that's going to cut the concentration in half. So we're going to just know that doubling the volume decreases the concentration by a half. So what that means is the calcium ions are now going to have a concentration of 0.005 molar. And we're going to use the same trick for the carbonate. The carbonate would be 0.1 molar here. So if we cut that in half, because we've doubled the volume from 100 to 200, the carbonate is going to have a concentration of 0.050 molar. A lot of times we're going to run into this situation where we're doubling the volume because we're combining equal amounts of two solutions. If they're not equal amounts, you do then have to use C1V1 equals C2V2, which adds some complication to it. But for now, we're just going to work the slightly easier problem where the volumes are going to add together and they're just going to double. All right. So now, and this is first semester material, so sometimes you're a little foggy on this, and that's understandable. So you may have to go back and review C1V1 equals C2V2. If you took chemistry elsewhere, you may have learned this equation as M1V1 equals M2V2. I prefer to emphasize that it's general for all concentrations. All right, so now let's look at the second part of the problem, which says, will a calcium carbonate precipitate form or not? And we're given the KSP of calcium carbonate as that value. So what we're going to do here is we're going to calculate Q. Remember, Q is the same as the equilibrium expression, but just we're going to plug in values that aren't at equilibrium. So for this guy, we need a reaction first, right? So the reaction is always going to be the precipitation. In fact, let's go to a new piece of paper. We'll keep this part here. All right. But remember that the reaction here is going to be the dissociation of the compound. It is not like first semester where we would have said, oh, we're going to write calcium nitrate plus sodium carbonate. Because the math that we need is going to be a Q versus K calculation. To do Q versus K, we need to use the K, which means we need to use the KSP. We have to have the solid as the reactant dissociating into its ions. All right. It's just a different way of thinking about the same phenomenon, okay? Instead of thinking it as the precipitate forming, we're gonna ask ourselves, will this equilibrium get set up or not, all right? So we know the K value because we've been given it. So what we're gonna do now is calculate Q. Well, Q is just going to be the calcium concentration times the carbonate concentration. Why is that? Well, we have a 1-to-1 concentration, 1-to-1 mole-to-mole ratio here. So the coefficients up here are just 1. So it's just calcium times carbonate concentration. Normally that would be over reactants, but remember, one of your only reactant is a solid. So we're going to pretend its concentration is 1. All right. So now we're going to calculate Q based on the numbers we solved for back up here. All right. So we're going to plug those numbers into our Q expression, and we're going to get 0.0050 times 0.050, and I could do this in my head, but we're going to make sure I do it correctly, so we're going to use the calculator instead. And that's going to give us a value of 2.5 times 10 to the minus 4. Now remember, the K value for this reaction is 5.0 times 10 to the minus 9. All right, so what that means is that the Q value is bigger. Remember, this means fewer zeros out in front, right? So that means that the Q value is going to be greater than K. And anytime we have a Q greater than K, that means that these numbers here are too big. We've got to convert some of those products back into reactants, okay? So if the Q number is too big, you have, that means that the product concentrations are too large. The only way to bring those numbers down is to turn products into reactants. So what that means is that, in fact, yes, a precipitate will form. The precipitate of the calcium carbonate will form because the reaction is going to proceed in reverse. All right? So anytime you have these problems, there's a couple of things you have to do. The first thing is you have to remember some first semester molarity concepts, all right? So where if we combine these two solutions, we're going to use the new volume of the solution as our V2. However, in this case, we can shortcut it because we have two 100s and we're going to 200. So we're doubling the volume, so we're cutting the concentration of our ions in half. Then we're going to do the solubility reaction and do a Q versus K calculation. If Q is greater than K, the reaction proceeds in reverse, and that means in reverse in this case means precipitate. If the reaction were to go in the forward direction, we would not observe a precipitate at all. It would mean that the concentrations of these were not large enough for the solution to be saturated.